Right then. Apologies for that. Right then. Okay, a few technical glitches there, but I'm hoping that it's all working pretty good. I've got about 17 screens in front of me, so hoping all goes well. It's probably not going to, but it's the first time we've ever live streamed before, so we'll just roll with the punches. On the side of your screen, you can probably see the chat there. I've enabled slow mode so I don't get inundated with lots and lots and lots of questions and things like that. If you've got a question, put it inside. I'll endeavour to answer it. I'm not going to go through every single topic. If you want something specifically, then I will go through it. So what you'll see on your screen now are all the AS components. So tomorrow is the exam. And people are just saying Big Man John on the side, which is fantastic. Anyway, so tomorrow morning, AS exam. There's 17 topics in total. The Component 2 exam will cover most of Chapter 9 on there, which is algorithms and programming. The only thing that you need to be aware of is the sorting and searching algorithms. They're going to be in the first component. And there might be some algorithms and programming questions mixed in there, but the majority of it will be in the Component 2 exam. I've invited my A2 students to come and have a look at this as well, because half of their content is basically the first year stuff anyway. So there's some people asking for lexical analysis. We'll quickly recap the compilation process anyway, actually. So I'll just find some of that stuff for you, and then we'll go through and we'll start with the compilation process then, shall we? So like I said, if you've got anything, just add it to the right-hand side. I suppose this live stream's much easier than coming in at lunchtime and doing it, I suppose. So let's have a look at this then. So I've got the exam papers as well in case we need to go through any of that stuff. But we'll start here, shall we? So the compilation process is quite technical really for AS level, but you'll be expected to comment on quite a few different steps of the compilation process. So I'll just hopefully, yeah, my tablet's working okay, right? So compilation process. We've got about 6 different steps to the compilation process. So step 1 is lexical analysis. So my students will be aware that lexical analysis, I always reference Susie Dent. You know who that is, off Countdown. If you don't know who it is, Google it. You should do. So what is the point of lexical analysis? Well, the point is you are going to remove all the white space. That all gets removed. Why? Because we don't need it. It's just wasting memory. So the white space gets removed. And what else gets removed? Well, anything that you put an apostrophe on in VB. So comments get removed. Now I must check the comments as they keep streaming in. Oh, Tom's in. There we go. Hi, Tom. Yep. So I'm just looking. I'm just reading the comments. That's why I'm pausing for a second there. There's been 1 or 2 questions on the compilation process. That's a question that's just been asked there. Apparently there's 2 live streams. I had a bit of a technical glitch. But back over to the compilation process, I'll keep referencing these questions in the right side. They're just distracting me, that's all. So the lexical analysis, white space gets removed and the comments get removed as well. And the code gets tokenized. So really, if you think about what tokenization is, I'll just quickly write some code. If name equals string, which is John, then do something. So that's the first line of my code, and tokenization happens on the line, so it will take off anything and split things up and box everything off. Now, there's two different things here. There's things called reserve words, and there are things called identifiers. So you got to look at this. And the computer, basically, the job of the compilation process is to take all of the code that you've written at your high-level language. So you're talking English is the highest level language. You've got fifth generation languages, which is artificial intelligence and machine learning. You've got fourth generation languages is the stuff that you program in, which is your Python and your VB and stuff like that. Then you move down to your lower levels, your assembly language, and then you've got things at the bottom, machine code, and then you communicate with the hardware. So that's the lowest you can get to after machine code is the actual hardware itself. And the computer is, remember, it's dealing with switches, so it can deal with on and off, basically. So I've just tokenized that there and said, well, if is a part of the language that you write in, so that will be a reserve word. Name might be a variable I've made, so that's an identifier. You've got equal symbols, speech marks, things like that. That's all written in the language. The string itself is what I've written, so that's an identifier. And this is the first step. So if we have a problem at the lexical analysis stage, then what we're going to do is we're going to basically throw up an error and say, there's no point in compiling any further because we have an issue here. The next step after that is lexical analysis. So not lexical analysis, syntax analysis. So this is common where errors get made. So you will make an awful lot of errors in this syntax part. So syntax analysis, we create these things called symbol tables, and data dictionaries, and the computer's idea of a data dictionary gets created here. So syntax analysis, think about what syntax is. It's the way you've written your code. So you've got the tokens that you've just created, they get checked. And the reason why they get checked is because they need to abide by the laws of the language itself. And we use this thing called BNF. And if you're not a second year student, you won't really know what that's all about. We can also use these things called regular expressions as well. And regular expressions are basically written so that they force you to use the grammar of the language itself. And then at this point, you've got abstract syntax trees, and that's really important. Abstract syntax trees play a massive role in the compilation process because they will basically be converted directly into machine code, because each node on the abstract syntax tree gets converted into machine code as a one-to-one or a direct mapping, they call it. So let's have a look at the syntax trees. And it might be something like A plus B, but each one gets separated into its nodes. And then this will get some sort of binary with it. This will get some different binary, and then this will get like another piece of binary. So at the machine code generation level, you're going to have a process where you're going to mix these together and you're going to produce a word that can be processed by the computer, because the computer can't understand what's going on here. It's got to turn it all into machine code. So if it doesn't fit the grammar of the language, we produce a syntax error. Now, there's one point that's missed with the diagram in the textbook, and this is semantic analysis. So semantic analysis is all about making sure the way we've done things is correct. So we're talking about the way that we have ordered our variable, our assignments and things like that. So I'll give you an example of that, actually, if I can find what I'm looking for, which is the eraser. So Let's get rid of some of this. So at this point, semantic analysis is going to check that all the variables have been declared. Now, your IDE, your integrated development environment, will try to do this in the first place. What it'll try and do is it'll try and check that the variable has actually been created, and you might see the green squiggly line in VB.NET, and that's saying you've declared this in memory, but you've not actually sorted it. So in semantic analysis, we have a check to see if all the variables have been declared. We have making sure that with things like, let's say we had a string, doesn't matter what it is, the string has speech marks, and we said assign that to the value of a variable. Okay, if you read this is actually incorrect in the language, because we don't assign variables to strings, it's the other way around. So we have a variable and we assign that the value of the string itself. So it'll be one way or another, and semantic analysis checks and makes sure that what you're trying to do is correct. So this one will pass and this one will fail. And it also checks that the operation is legal. So there's no mixed mode arithmetic, it's called, where you have greater than or equal to. That's perfectly accepted by the language. Whereas if you had equal to or greater than, it would not allow this. Okay, so it makes sure that you have a set structure, and that's what semantic analysis is all about. And then once you've created and you've gone through the lexical, the syntax, semantic analysis, and you've actually got your final syntax tree, then you get to the machine code generation part. And what that is you're actually going to turn your syntax tree into machine code. And at that point, you're also going to optimize as well. So optimization plays a real big role, and there's less of a focus now on you lot writing all your code and actually getting better. They don't care anymore. So your machine code generation part is actually going to optimize it and make your code more efficient. I'll just check them questions in a minute, because I'm aware that a lot of people are commenting at the moment. So once you've optimized your machine code, don't forget the final one. The final step is linking. So if you've used any libraries or what they call standard functions like input boxes, message boxes, these are things that are not written by you. They're written by somebody else in the programming language. You've got to link your libraries into your machine code, because if you compile it, then you're going to get a one standalone exe, and that's the compilation process that a compiler does. Remember, there are three types of translators: compilers, interpreters, and assemblers. So compilers will go through all the way through the code, protect your intellectual property, and produce one exe. Interpreters will go through line by line and check any errors, and the errors can be found on the line, and they can be run on any platform, providing that you've got an interpreter installed. And finally, you have your assembler, which is just for assembly language. So let's have a look at some questions, and let's tackle the next thing in here. Okay, I'll try and get through as many as I can. Oh my goodness, there is a lot of comments. Okay, so let's have a look at what we've got. So we've got truncation and rounding, waterfall and agile, mantis and exponents, serial sequential. Yeah, I have made videos on that, you're right. Sorry, no neural networks in VB. Okay, so what's the thing with the data manager? So Louis talking about in legislation, the Data Protection Act, you've got the data subject, which is you. You've got the data controller, which is technically Jane Clark, and then you've got the ICO, the Information Commissioner. So that's a government role. That's what Louis is talking about. Who is Matthew Cockcroft? How annoying. Okay, there's a bit of Mantis and exponent stuff. There's so many comments. Who knew this would be that popular? There is a video on that if you're looking for data representation. Yep, someone has created a fake John. Okay, so let's have a quick go of files, truncation and rounding. Okay, so we'll do a bit of truncation and rounding for Luke, shall we? So I'll find that for you now. Just remember, let's do some truncation and rounding. So what's going to be asked about truncation and rounding? Well, think about it like this. One is more accurate. Okay, that's what the examiner is going to be looking for. Now, it's not always the case that truncation is less accurate than rounding. Depending on the numbers that get given to you, you might have to work it out. So let's say we had an 8-bit number for both of these things. Let's say we had 0.1. Actually, let's give you a better example. 0.101101, and that's in base 2, obviously. And let's say we were doing truncation with this. So we're going to truncate to 4 bits. Now, if you were truncating to 4 bits, we would end up with the number 0.010. Okay? Now, you've chopped the rest of the bits off, and you don't care what the number is after that line there, because we're only going to 4 bits. So the point of this is, if you were doing that, in order to work out the accuracy of this, you would do something called an absolute error. So you might have heard of this in science. So an absolute error is going to be the original number minus the truncated number. Apologies for my writing, it's terrible. So, just check them questions again. Yeah, they're still coming in. Okay, so I'm just checking the questions again. Right, so the absolute error is there. We've got something else called a relative error as well, which gives you the percentage. Now, the lower the percentage, the more accurate of the relative error. Now, you can't work out the relative error without using the absolute error. Really struggle to write on these things, and I've spelled that wrong as well. So, absolute error and the original number. And that'll give you a percentage. So that's what you're going to do with that number. Now, rounding is slightly different. Rounding is where you're going to chop off the 4 bits, but this bit is important here. Now, if we cut to 4 bits with rounding, it's the same in normal mathematics where you have a 5. Anything greater than or equal to 5, then you're going to round up basically. So In binary case, it's a 1. So if this is 0 and this is a 1, in this case, we will end up with 0.011. Okay? If this was a 1 and this was a 1, this would just remain as a 1. Okay? And then what you would do is, once you've got this number and you've rounded, you would do the same thing again, the same absolute and relative errors, and you would work out what the percentage was. And it's really this down here that's important. Okay, the lower that number is, the better it's going to be. I think for this one, if you work this out, the truncated number is going to be 28.9 after a bit of quick maths. And then the rounded error is going to be 6.7. Okay, remember, the lower the number, the more accurate it's going to be. And it's not always the case, it's just the case in this example here. All right, so that's truncation and rounding right there. So let's have a look at what question is next. Just delete this layer for you. Right, what else we got? Okay, I won't go through files because there is a video I posted on file handling that people asked for. Currently got 40 viewers. Look at that. Who'd have thought? Okay, so let's have a look at some. What we'll do is we'll have a look at an exam paper, shall we? So let's have a look at the 2016 paper. So if at any point people get lost, then I'll just start going through the paper, and then you can let me know if you've got any specifics on that. So looking at the first question on every paper, what you're going to get tomorrow is you're going to get Boolean algebra. That is a definite. You're going to get data representation, so that's a binary question, which is perfectly fine. You should be able to handle those questions now. So looking at this here, I'll see if I can edit this for a second. Back over to my sketchbook. So hopefully you can see that in there. So nice and standard. I mean, my class has been through tons and tons of these, and it shouldn't be really too difficult for you. So 0 and a 0 or a 0 is going to be a 0. 0 or a 1 is going to give you a 1. 1 or a 0 is going to give you a 1. And 1 or a 1 is going to give you a 1. A and B. So the and rule states that both conditions need to be 1 in order for you to retrieve a 1. Anytime you have a 0, it will always be 0. A XOR B is going to return 0, 1, 1, and 0. Now you're looking for opposites, so as long as you've got a 0 or a 1, or a 1 or a 0, it's going to return 1 every time. And then the final one, you've got A, so you have to take the A column, and you have to OR it with the not. So yeah, A or not B. So you've got to basically flip this one. I would probably put another column in here and flip all these terms. 1, 0, 1, and 0. And that means you're going to get yourself 1, 0, 1, and 1. Okay? Now, what you're doing here in this second question is there's a couple of things you've got to do with logical operations, and one of them is encryption, one of them is masking, and one of them is clearing registers. Okay? So I'm just checking the questions again. Some people, compression, standard functions. Okay, so for Tom, standard functions are things that you use inside Visual Basic, for example. They are things that are written into your programming language. So it saves you time. It's things like .toString will convert it to a string. You've got casting to integers, that sort of thing. We'll have a look at a dry run in a minute. Anis is asking for masking. So that relates to this question here, really. We've got masking. Show how a logical operation. So what logical operations have we got? We've got anding, oring, notting, them sort of things. So in this case, if you're talking about showing the state will be an and logical operator. Okay, so that's the most significant or the leftmost bit. So that's what it's asking for. It's asking for the most significant leftmost bit. So it's this one here it's looking for. It wants to show the state. Now, as a human, you can see that, obviously. So anding, in order to get that, if we write out the register again, which is what was given to us in the question, our mask would be 1. So whatever bit it asks for, that would be a 1 in the masking process. Okay, everything else gets a 0. So make sure I do the right amount. Okay, so that's what it's going to be. That's my mask. Now, just by putting that as your mask, you're going to get 1 mark. It's simple as that. If you show how a logical operation such as and, yeah, that will get you a mark. All right. Then all you got to do is you've got to compare them. So 0 and a 1, if you and those two together, will give you a 0. Remember what I said before? When you're anding, if you ever and with a 0, it's always going to return 0. The only time you're going to get a 1 is when it's a 1 and a 1. And if you look at the most significant bit, that's what you're going to get. That's 3 marks there. So that's your masking stuff sorted. I'll have a look at a mantissa and exponent question in a minute, because a lot of people are asking for mantissas and exponents. If you're asking about network standards, so I think that is, I don't even know who that is. But if you're asking about networking standards, you're thinking about protocols. That's all. Yep, file transfer protocol. Okay, I'll go through some protocol stuff. Yep. Okay. Right. Let's have a look. A lot of people are asking for exponent and mantissa questions. So let's find one of those. And let's do one of those for you. Make sure that you cover your binary. If you do well in your binary tomorrow, however many marks it is, it's usually worth between 8 and 10 marks-ish. So you'll do all right in that. Handshaking. Name a standard network protocol describing its function and importance. I'll tell you what, let's quickly go through this question here. Let's add that in. Okay. So my class will be aware that if you're looking at handshaking, handshaking is the process that establishes whether a device is ready to communicate. And it's as simple as that. So that is the definition for it, and it will not change because handshaking's protocol is standard. So if you're thinking about name a a standard networking protocol describing its function and importance for 3 marks. Now, think about what it's asking you for 3 marks. The first one is, can you define a network standard protocol? So, for example, file transfer protocol or FTP. If you are looking at writing FTP, then I would always expand that acronym because I don't want them taking marks off you for no reason. Think about the description of it. So the description will be worth 2 marks in this question. So, for example, let's go through the network protocols then and let's understand what they do. So we'll start with FTP, okay? File transfer protocol. That will get you 1 mark, okay? Now, it allows the transfer of large files over a network. That will also get you a mark, all right? Now, it says in the question, you've got to state its importance. So why is FTP important? It's important because the FTP protocol has built-in error checking and retransmission requests. So when you send things over a network, file transfer protocol can pick up on if you've lost a packet, and if you need to resend it, the FTP protocol handles that. So FTP will get you 3 marks for that. You've got HTTP, not to be confused with HTML, okay? Yes, we're talking about hypertext transfer protocols, but it's not hypertext markup language. The markup language is a paradigm, okay? So don't get confused. HTTP, if you want to look at its description for 2 marks, you're going to have to say it allows the transfer of multimedia web pages over the internet. That's 1 mark. And it's important because the HTTP protocol allows for multiple different web browsers to display and format web pages as the original author intended. So it doesn't matter if you're using Chrome, Firefox, Internet Explorer. I don't know why I'd use Internet Explorer, it's garbage. But if you're using that, then it'll display it exactly as it intended. Remember, it's a standard networking protocol. We're trying to standardize what's going on the web. So that's HTTP. What about SMTP? So SMTP and IMAP. SMTP. There we go. SMTP then, Simple Mail Transfer Protocol. As soon as it says mail, then you know you're going to be talking about email. It's obvious. And if it's not obvious to you, get a grip. So it's important as the SMTP protocol provides a standard way of transferring emails between 2 different servers, okay? So if you said it allows emails to be sent over a network, then you get a mark. It's obvious, but you get a mark. Then if you said it's important because it provides a standard way of transferring emails between 2 different servers, then you get 2 marks. Now, it's talking about servers. It's because it's apps like Outlook on your phone. Outlook, the way it works is it communicates with a server and it'll download not an awful lot. It'll take maybe 5 or 10 emails, and then if you scroll down, you request more information from a server. And SMTP holds all that, and that saves memory on your device because it's using a server. Now, thinking about IMAP, okay, IMAP is Internet Message Access Protocol, and it allows emails to be transferred between computer systems via the internet. So this might be your internal intranet sort of work email, for example. And it's important as IMAP provides a standard way of transferring emails between 2 different servers. Even though I said servers, it's not the same as SMTP because messages are stored on the server instead of a mobile device. And again, this saves storage space. So the point here is that IMAP is all about the internal. We use it. It's not really used much anymore. SMTP tends to be the one that people use because we're talking about lots of emails on systems, etc. So just be mindful that the first description is it allows emails to be transferred between computer systems via the internet for IMAP, and SMTP it says it allows emails to be sent over a network. Okay, so that's the distinct difference between those 2. Dynamic Host Control Protocol, sometimes it's Configuration Protocol, but in mark schemes you tend to see it being called Control Protocol. So that's DHCP, Dynamic Host Control Protocol. Okay. Now, the point here is that every computer has an IP address and it assigns IP addresses to devices on a network. So that's your first mark for that. It's important as the DHCP protocol ensures that unique or dynamic IP addresses are allocated. So the point here is that if you turn your computer off, your IP address gets freed back up and sent into the pool of IP addresses. And that means, that's what dynamic means. The point being, if you had a static IP address, just think of how many IP addresses you'd need. You need one for your phone, your computer, your watch if it's connected to 3, 4G, whatever. There's not enough. There's just not enough. So, what you got to do is you'll send out, turn the computer off, IP address disappears, turn the computer back on, IP address comes back. Okay? So, 2 marks for that. One for saying it assigns IP addresses to a device on a network, and the second one being that it ensures that unique or dynamic IP addresses are allocated to each device. Okay? And that means it allows addresses no longer in use to be automatically returned to a pool of available IP addresses. Then we've got UDP. UDP. What's it used for? Well, it's usually used for video or audio. So it sends datagrams across a network with very few error recovery services. The point of the error recovery services is saying, well, you don't need to have all the packets in order to produce the audio or produce the video. And if we were waiting for retransmission, then you'd just be buffering or waiting for your video to load for ages, and that's not good. So send datagrams across the network with very few error recovery services for 1 mark, and this is important. For example, video and audio streaming protocols are designed to handle the occasional lost packet and need to receive new packets rather than the retransmission of previous ones, and that's your 2nd mark. And really, the last one is not necessarily one protocol, but it's a suite of protocols, which is Transmission Control Protocol, Internet Protocol. Okay, and this allows any networked computers to communicate with each other. That's 1 mark. This is important as TCP IP specifies how signals are routed and transported around the network, and it reduces the need for gateways to convert signals into different protocols. Now, it goes through a series of steps. It's you at your computer level sending something across the network, going down all the protocols, getting sent across the transmission medium, and somebody receiving it on the other side, and it goes through the same protocols because you've done the handshake, and it'll go back up the levels of protocol and then be displayed on their computer in whatever shape or form. Okay? So that is, well, that's all your protocol stuff anyway. So let's have a look at a simple, or not so simple, binary question. You've really got to smash the binary. If you don't, then who knows what can happen. Like, good luck to you, because you should be getting it all right. I'll check another one. So let's have a look at another question. What have we got? There we are. Okay. Let's do this set of questions then. So I imagine my students would be bored to death of these questions, but practice makes perfect. Let's have a look then. Right, so I do hope you can see that, because I have absolutely no idea what you're seeing or what you're hearing, or if you can even hear me, for that matter. There are so many comments. Right. Let me just write these down. Because between all the riffraff of what you lot are saying, some people are actually asking for stuff. So I'll see how far back it goes. Right. Tyler's talking about ASMR. Shows his concentration throughout the year. Mantises and exponents I'm doing now. I've done FTP, protocols. Yeah, done that. We've got Paradigms. I'll do some stuff on paradigms. Yes, this video is being saved at the end. Done FTPs. Yeah, done FTP. Yeah, done that. John's not a fraud. You're a fraud. ASCII and Unicode. That's a good one. Got that. Okay. No, I wonder who Michael OAFC is. A garbage football team. Fetch, decode, execute cycle. Yeah, I can do that. Fetch, decode, execute cycle. Expert systems. Yeah. It's funny how it's my class coming up with the good suggestions, apart from Tyler. HDMI cable. Yeah, good luck with your HDMI cable. Object-oriented programming. Yeah. Entity relationship diagrams. Entity relationship modeling. Yeah, I'll do a bit on that. Okay. Snowden. Yeah, somebody messaged Tyab. Tyab's probably not got a clue what's going on. 480p. I've not touched it. What are you on about? Dan. Multiplexing, voice, speech, character recognition, sequential, random. Okay. Compression modes. Yeah. Okay. Yeah. Changeover pilot stuff. Okay. Methods of changeover. So you're talking pilot, phased, direct changeover. Okay. Yeah. Jordan Jackson. Oh, one of my ex-students. Look at that. Who'd have thought? Hi, Jordan. Programming questions, dry running. Okay, yeah. Programs on Friday. Take a break for Aftar, John. Well, if Aftar's not here, good luck to him. Right, let's get going again. Tyler, be quiet. Right. Let's do this question first. Let's see how bad your binary is. You're probably not doing it, but it's worth doing anyway. So here we've got converting the hexadecimal numbers. How can you tell it's hexadecimal? Well, you see the little 16 there. So that's what tells you if it's hexadecimal or not. If you see 2 there, it means it's binary. If you see 10 there, it means it's denary. And that it's a normal decimal number. So our decimal-based systems. Right, so let's have a look then. 3E. 27, it's not 27, it's 27. Okay, if you say 27, it makes me angry. So thinking about it, 3 and the E, well, what is 3? 0, 0, 1, 1. In 4 bits, what's 4 bits? 4 bits is a nibble. And E, there we are. Then you've got 2, 7. Now, if you literally just split these up and you're doing them, and your 7 is your 0 and your 3's in there. Now, if you just split them up like this, 2, 7 and your 3E, okay, then you get 2 marks already. It's literally as simple as that. Now, it wants us to convert the hexadecimal numbers into 2 binary numbers. I've done that. And using binary addition, calculate the number that would result from adding them. So it can't be too difficult, like, really. I'm not looking at the comments. It's too many flying in. I'm just going to do this before I lose my concentration. We'll get to the harder question in a minute, the one that requires John's famous 4-step process. So 0 and a 1 gives you a 1. 1 and 1 is 0. Carry the 1. 1, 1 and 1 is 1. Carry the 1. 1, 1 and 0 is 0. Carry the 1. 1, 1 and 0 is 0. Carry the 1. That is 1. Carry the 1 and 0. So that's what we get. And make sure you show your carry bits because that will get you a mark as well. Now the last bit, which is what people forget, is that it says here, convert your answer into a denary number. So in order to do that, you just put your headings at the top, 1, 2, 4, 8, 16, 32, 64, 128, and you add that up. You 164, 2, and that will give you 101 in base 10. Okay, you can check my work. I'm fairly sure. If you've got time at the end, then make sure you double check it. Dan, it's not pronounced 11. It is 1-1. Okay, now the next one, using the number -27 as an example, describe 2's complement and sign a magnitude representation in an 8-bit register. So I won't go through that, but I'll explain it for you. If you've got Kevin or Phil, you may have done the other methods of 2's complement as well. Oh, I didn't mean to do that. So -27, 2 methods of getting into a negative number. 2's complementation, you would turn the number into a normal binary number, i.e. 27. You're probably using 8 bits because it says an 8-bit register down there. And then what you'd do is you would go up to and including the first bit and flip the rest, and that would give you -27. Or you can flip all the bits and add 1 at the least significant bit, and then that would give you -27. So there's 2 methods of 2's complementation. I like to stick with the go up to and including the first bit and flip the rest because it's nice and simple. I don't have to do any adding at all. It's just really straightforward, and students tend not to lose marks for that. The second one, describe sign and magnitude. So sign and magnitude is where the most significant bit is represented using a 1 or a 0. 1 being negative and 0 being positive. And that's it. And then you just show it using 27. Then I get over to this one here. So this is the one that tends to trick people a little bit. So we've got, in certain computer systems, real numbers are stored in floating point form using 2's complementation. Now, don't worry about that, because if you've got a positive number like we have here, that makes absolutely no difference. We've got 8 bits to represent the mantissa. Remember, the mantissa is the value of the number. And then you've got 4-bit exponent, which tells you how many places to move the decimal point. Convert 8.75 into floating point form. So, let's do this then. We have 8.75 in the smallest number of bits. That is step 1. So if I get it right, 1.5.25, I believe that is 8.75 in the smallest number of bits. So that is 1. Okay, that's step 1. Step 2 is then normalize this number. 0.1000.11. If that's positive, that's always going to be 0. Always. Okay? Then, step 3. What we're going to do now is we are going to pad out to the correct number of bits. So I've used 1 bit, I've used 2 bits, 3 bits, 4 bits, 5 bits, 6 bits, 7 bits. I have 8 bits to represent the mantissa. I pad on the right-hand side. On the right-hand side. I don't understand how many people pad on the left. That really just baffles me. I've said it so many times. And if you do it, I'll find out who you are. Okay, and I'll get you. So, 8 bits there now. How many places do I need to move that decimal point? 1, 2, 3, 4. 4 places I need to move that decimal point. So my exponent, I've got 4 bits to represent it. So I'll have 1, 2, 4, 8. My exponent's going to be 0, 1, 0, 0. And then I'd fill in the rest of my number up here, because why not? This is the 4th step I'm doing over here. 0, 0, 1, 1, 0. That's 3 marks. 3 marks for them 4 steps. Okay. The last one, you just got to reverse the process, people. Reverse the process. So all you're going to do is calculate the denary value of the mantissa exponent and convert this floating point into a denary number. Now, What's it say first? What does it say? Calculate the denary value of the mantissa. I'll do that first, okay? If you look at it, okay, it goes 0.5, 0.25, 0.125, 0.0625. Add them together, and that gives you 0.6875. Okay? You could also have had there, if you think about it, you could also have a fractional number. That would be, each one would be getting down, so that last one would be 16ths. So you'd have to do it in 16ths. It'd actually be 11/16ths if you wanted to do it like that. Okay? But if that's just lost on you, just ignore that. Okay? The exponent is 3. That already gets me 2 marks. Okay? All you've got to do now is go 1, 2, 3, put your point there. So then this all gets gone because you've got 0.5 now because the point's changed. 0.5, 1, 2, 4. So that would be 5.5. 3 marks. 1 mark, 2 marks, 3 marks. Unbelievable. Look at that. Amazing. Are you right? Okay. Well, we're right. Looking down here. Yeah. Okay. Okay. Just reading the comments again. Wow. I don't know what you lot are talking about. Right. Right then. Some of you are so strange. Right. Let's have a look. Let's do something else. Let's go through. Michael wanted the fetch, decode, execute cycle. We'll quickly do that. Should be quite straightforward. So looking at this then. This is sort of the process of the fetch, decode, execute cycle. You've got to know what the components are. So the components of the processor are here. So you're probably used to drawing that. My class can draw that with the blindfold on, because that's what we do in class. So this is the CPU. The CPU has 3 main components in it. You've got to remember these shapes because you might have to draw these shapes. We have the ALU. We have which is the arithmetic logic unit, which is dealing with all the logical operations and all of the number crunching stuff. Then we have the registers, lots of different types of registers. We've got the control unit, which is for basically executing the fetch, decode, execute cycle. We've got input and output devices, which are standard things like your input device, your keyboard, your output devices, your screen, etc. And we've got memory. So this is the von Neumann architecture. All we're going to do now is look at what happens. There was a 4-mark question on how you load from RAM into memory. So we've got, not into memory, how you load from RAM into registers and actually follow the fetch, decode, execute cycle. So step 1, the contents of the program counter. The program counter's job is to keep track of which instruction you're carrying out. So the program counter, the contents of that is passed to the memory address register. So that means that the memory address register then can go and fetch it from the little mailboxes in RAM. So it goes to the address, gets goes to the point, basically says, I found it, what do you want to do next? MAR passes the contents or the data at that memory address. into the MDR. And the reason why that's done is because the memory address register, it can get on with the next job while the memory data register is dealing with the data. So once the memory address register passes over the data to the memory data register, the program counter is incremented by 1. And it's the process of pipelining, which speeds up retrieval. So the fetch phase is actually optimized to be faster. The memory data register then goes to the current instruction register and gives it the data. The data is then converted. So it's converted into its instruction, and we work out what actually needs to happen. So this is instructions such as, if you've done assembly language, you might have done add, sub, STA, LDA, they're sort of store at position in the accumulator, and LDA load into the accumulator, etc. That's what happens at the current instruction register. We understand what's needed. Then the current instruction register passes its contents into the control unit, and then the control unit then directs the operation of the processor. So it tells the computer's memory, the arithmetic logic unit, input-output devices how to respond to those instructions, and that's the fetch, decode, execute in a nutshell. The decode part is really step 3B, and that's the point of it. And all it's going to do is decode the instruction, pass it on, and it gets executed. And as soon as it gets rid of it and it gets put on the processor, the point is we're trying to keep the processor running as much as possible. If the processor sits idle, it's the most ineffective thing that your computer can do, which is really bad. So looking at, we'll look at paradigms then, because that's what was asked for. Let's look at some paradigm stuff. Just trying to get myself organized. So we've got a couple of different paradigms. The first one, the one that you may be used to, especially if you did Python at GCSE, yeah, it's the procedural paradigm. You've got, if you did Scratch, oh God, Scratch. If you did Scratch, then you need to have a word with yourself. But it's a visual paradigm. If you are using Visual Studio, which you should be, because if you're not, what are you doing on our course? Event-driven, that is Visual Studio, and VB.NET. And you've got markup languages, which is HTML and XAML, or XML, if you've ever heard of that. And then you've got number 5, which is mostly component 2 stuff, your object-orientated programming, OOP. Okay? No Louis, not Scratch. There we go. Hello, Harley. Tyler, what are you on about? Compressing videos to 1 pixel. What are you even saying? What are you even saying? I can do sequential, index sequential. There was a video posted on that, literally, over the weekend. You might want to have a look at that. Jordan, I'm not going to do anything from 150 sub mark. I'm after a play button. Compression techniques. Let me just add that in there. Right, so I'll add that to my list, compression. Okay. Right, so let's talk about some of these then. So we've got procedural programming. So it will run from start to end sequentially unless a control statement is hit. So if you don't know what a control statement is, it's an if statement, a selection it's called. If you see the word selection in your exam, it actually just means if statements. If you see iteration or repetition, it means looping of some sort. And then if you've got in sequence selection operation are the three main constructs of programming. So you're going to run to the start to then sequentially until a control statement is hit. You've got a logical step-by-step process in procedural programming, and that's why it's good for solving problems, and they obey ordered instructions if given to it. So you give the instructions in order. If you've got a procedure or function call, then yes, it will go to a procedure and it can be ran and it will jump into different parts of the code, but it will always return back to where the procedure is called and continue running, and that's procedural. So they're good for carrying out actions and calculations, and the programmer can precisely define each step when performing a task, and there's quite a tight control over the underlying of the hardware in procedural programming, which is why people that do electronics like to use procedural programming, because it follows nice and structured order, and it's used in large complicated programs, mainly programs on mainframe computers. Okay, so the good thing about procedural programming is it involves modularity. So that's where you take a complex task and you split it up into smaller, more manageable chunks. And languages like C and Python, like I said before, often use procedural programming. Visual programming are things, well, I've said Scratch because Scratch is like the main one. It's the bane of my life, okay? But it's likely the first programming paradigm you'll come across. And the reason is because it's really intuitive and the user interface is really simple to build programs. And the point is, it helps people build programs rather than solely just relying on text. Usually it's an expert knowledge that you need to write text and write code. You need that prior knowledge beforehand, but people can use Scratch and just trial and error and get it right and drop blocks in and try it and see what happens. So the point is, the dragging and dropping and the clicking and stuff like that those are actually events inside visual programming paradigms. So in Scratch, you drag and drop blocks and you make use of that event-driven programming paradigm, but it's all about how the user interacts with the graphical user interface, or GUI, and that's what visual programming is all about. And it eliminates the syntax and it makes you focus more on the logic of the problem rather than the syntax of what you're actually doing. With event-driven programming, it relies heavily on user interaction because the users actually drive the events. So in VB, when we make buttons and things like that and we program through the button and through the front end, the user interface, that is all event-driven. Okay? So it's okay for different paradigms to be combined together. The point is that programs will sit in a loop in event-driven and it will wait for the user to perform an action. Similar to how your Alexa or your Google Home thingy will loop around listening for you to say, "Hey Google" or Alexa or whatever. Okay? So when the action occurs, a function will trigger. It's called a listener, this function, and it will run and process the action that you've given it. So it could be a timer event. It could be you pressing your on and off button on your computer. So with event-driven, the listener won't just continue to just run and action your code. It will wait. It'll keep listening, but it'll wait to see what's triggered. And there's lots of different triggers that you can program in, especially with Visual Basic. And things like games make use of event-driven programming and visual combined, really. But event-driven programming is used in almost all the paradigms, but it's fairly common to have. So things like Java and VB and things like that, they have built-in event-driven programming aspects. If you think about markup languages, you've got HTML and XML. They're the two main languages used in markup, and you've probably heard of HTML before, but markup languages, you add comments or markup to plain text in order to offer meaning to that text. So in HTML, you will add chevrons and you will give commands in order to produce in a web page, in a browser. It will then read those chevrons and commands and turn it into something else. And that's the meaning part. So you take plain text, give it some chevrons, like a H1 tag, for example, and a P tag, which is a paragraph, and it would produce it. In order to close those those chevrons, you'd use a forward slash, and then close the bracket at the end. So if you don't know what HTML looks like, if you just Google HTML, you can have a look, and you can explain that in your exam if it comes up. So markup languages are not programming languages. I'll express that right now. Okay, they are not traditional programming languages. You can add things to them like CSS to give it style, which is cascading style sheets, or you can add HTML, not HTML, JavaScript, and that will provide a sort of programming environment and get more like programming, but it's not a traditional programming environment. The last one, object-oriented programming, is actually really effective. The point being is it tries to reduce the repetition in code. So procedures, like we was looking at before, procedures and procedural languages, procedures and functions are replaced by objects, classes, and methods. So a class is a template that will hold object attributes and methods. Attributes are like your variables, and your methods are like your functions and procedures, and your objects are your different classes. So they both procedural and object-oriented programming offer modularity in code. So it's breaking down really big tasks into smaller tasks, but it's making use of more reusable code. At AS, we've got to look at encapsulation, and we've got to look at abstraction, and we'll have a look at inheritance is the main one at AS, and we've got to be able to explain classes and objects and methods. So an object, like I said before, is a combination of methods and attributes that can operate on the data, and a class is definition of an object. So it's a template for defining the method. So I always draw on the board my car. A car can have its children. It can have a Ford, a Jaguar, and Aston Martin. They are all of the car class. You were all, like I said to my class, you were all instantiated from your mother. You were born of your mother, and you inherit those things. Tyler, CSS is not your favorite programming language. Okay, so the point being with a car class is it holds all the common attributes of the classes, the subclasses. So the top class is called the parent class or the base class, and everything from it is called a subclass or a child of the parent class. In your Comp 2 exam, you'll see at the top, if Michael's still listening, at the top, attributes, and at the bottom, methods in your little box. And you'll see public and private methods, but that's more for component 2, so I won't really go through that at the moment. Encapsulation is the hiding of the implementation. It's hiding away certain things from developers and also the user. And the point being is we might not want people to change certain things in the class. So in your car, you might want people to change the speed by pressing the accelerator. Michael, I'm not your dad. We might need to change things like the accelerator, increase the speed, etc. But we don't want people to change the maximum speed that the engine can handle. We might not want people to change the brand of the car, for example. So all that stuff is all programmed in, but we don't want people to change it. Inheritance is like exactly what goes on with your genes, with your mum and your dad. You are not basically a result of them two, and you will inherit some genes from them. And it's exactly the same. So we might have common methods and attributes. There's no point in rewriting it out in every object. We might as well have a parent class, and we will inherit from that parent class. Abstraction. Abstraction is a very simple concept, even though it's quite difficult in reality. If I drive to work in the morning, I don't know how my engine works. I don't know how my car works. I just get in my car, press a button, and I put the clutch down, put it in gear, and off I go. The engine's doing all sorts of crazy stuff, but the complexity is abstracted away from me. It's all hidden. And that is the 3 things that you need from that. So what else is on my list? Shirley's Fine Reese. So ASCII and Unicode. Should I have a look at ASCII and Unicode? So if you think about it, ASCII is quite simple, and so is Unicode, to be fair. You might have to explain different character sets. So what's good about ASCII and what's good about Unicode? Well, Unicode is used more frequently now, so Unicode uses an awful lot more bytes, really, than ASCII, because ASCII will use 8 bits or bytes, or you can even write in your exam 7 bits ASCII will use, and it's a standard character set, and every letter and number and character will have a specific 7 or 8 bit value. Okay, now that's okay for Western languages, but the problem is, what happens if we introduce Chinese or Japanese or languages with massive character sets? Then it simply does not have the bits to use. So the reason why we have 8-bit is because we have extended ASCII now, which compensates for a few more characters and a couple of emojis and stuff like that. But Unicode really is the way forward. All right. So Unicode is used for multiple character sets, and it's absolutely massive. It's huge. And really, what you expected to do, you're expected to compare Uni and ASCII code, and the focus will be on what is the main advantage to using ASCII and what's the main advantage to using Unicode. So if you say that the range is much larger in Unicode, then that's what you'd get your marks for. And the fact that you can host multiple character sets in in Unicode, is much better than you can in ASCII. I'm just looking at the comments again, very briefly. Interesting. The questions tend to get asked on ASCII and Unicode every now and again, and they'll come along with your data representation questions. So watch out for that. What else do people want in there? Okay. While we're here, I've just found this stuff here. Let's just have a quick look at some of this, because I found some more accurate details on ASCII and Unicode. You will have to make sure that you understand the units of measurements. So from smallest to largest, if obviously you know what a bit is, a bit, a nibble, and a byte. A kilobyte, a megabyte, and a gigabyte, and a terabyte, that's sort of the extent that you'll get asked to go to. You won't be asked any more than a terabyte. But the reason it's 1024, you can probably imagine it's in base 2. That's the reason why, really. Thinking about ASCII and Unicode, it just can't hold other languages. So when I talk about word length, if you know what a bit and a byte and a word is, remember what I said, a word is any set of bits that can be used in one clock cycle on the processor. So nowadays we have 16, 32, 64-bit. It's usually 32 or 64-bit processors now, and that's why we can extend ASCII further. So we brought Unicode in, and we can deal with Japanese, Arabic, Hebrew, much larger sets than that, and we can do 4 bytes in Unicode. So what is a byte? 8 bits. So it's plenty. We've got loads and loads there, and that's why you've got on your iPhone all the different types of emojis that you can have. A question that came up that a lot of people failed on across the full country was the data types. So it was actually this question here, and this really stumped everybody. So, what is the minimum storage requirement for a Boolean? A Boolean is true or false, so it's actually 1 bit. A character, an ASCII character, you could have said 7 or 8, like I said before. What about an ASCII string, though? So if a character is 1 letter, what about a string? A string it could be any length, couldn't it? But it's a string of characters, so whatever the string length is multiplied by the size of a character, which is 8 bits or 7 bits, whatever you said. So if you would have said 8 bits or 7 bits per character, then you would have been fine with that. Okay, and then your signed range there, if you look at the previous, you could have said integer was 2 bytes, so 8 bits per byte. So you could have 16 on that. Your Boolean there, so I'm looking at the end column around there. And you've got 4 bytes for Unicode, 1 byte for ASCII. This stuff is all simple memory recall, this really. And what they'll give you in your exam is explicitly like that. They could give you data types like that, or they could say, what do you recommend is the best data type to use for? And then they would give you an example to use on there. Okay, so be careful of that, because that's something that tends to pop up every now and again. So let's go back to our paper. Let's have a look. So just looking at Jordan there. Claudius, fine, Jordan. I'm not answering the baby's question. Just looking. Bikes and stabilizers, yeah, okay. Everyone's got fantastic detailed questions. Yeah, I'm just looking. Just going up the, yeah, okay, information, yeah, okay, right, fine, yeah. Entity relationship. Yeah, entity relationship diagrams. Let's have a go at those now then. Let's get some information up on entity relationship diagrams then, shall we? I've got some questions for you with entity relationship diagrams. So let's have a look at this one on here. Okay. Okay, let's have a look at entity relationship modeling then. Just trying to get these questions up. Strange. Okay, so with this, remember, entity relationship modeling, it's a part of the database part of your specification. So what you've got to do is focus on the three main entity relationships. So we've got a one-to-one. So I'll just draw these at the side. A one-to-one relationship. We've got a one-to-many relationship. And we've got a many-to-many relationship. And when you look in the second year, at normalization, this is not allowed, this many-to-many relationship. But in these questions, yeah, it's absolutely fine. No problems whatsoever. So all we're going to do, once I've finished faffing about with all this stuff, is read the question very, very carefully. The answers are all in the question. So a college uses a relational database system to keep track of which students are entered for which exams. Remember, a relational database it's not a flat file database. You start off with flat file databases, which is a full, huge database with one table containing all the information. A relational database is different. A relational database has multiple tables that are linked. They are linked with foreign keys. A foreign key is a primary key in another table. So every table has to have a primary key. Okay? Now, in order to link the tables together, we have a foreign key in a table and we share the information using the foreign key. And it links the tables together so we can pass information properly. So that's what a relational database is. To keep track of which systems are entered for which exams, each exam takes place in one room and can involve any number of students. One room can be used for any number of exams. Each student can be entered into any number of exams. Information is also held on the rooms in which exams take place, which include the room's capacity and whether or not it contains computers. So the first question here, define the term primary key and state one example of a primary key that might be used in this example. Well, all I would say is that if you read the question, again, all you got to do is read it really carefully and you can clearly see that the answer, a primary key is a field that uniquely identifies each record. If you use the word unique, it's likely you're going to get the mark because that's what it is. It's a field that is unique in the table, okay? And you could have said the room number is unique, the exam code is unique, or the student's ID is unique. You could have said anything else really. As long as it's unique, you're going to get the mark for it. So the second part really is draw an entity relationship diagram to describe the above scenario. So where do we even start? A college uses a relational database system to keep track of which students are entered for which exams. So thinking about it, I'm going to have a student entity. An entity really is a table. So my student table, I'm going to have an exam table. I'll space these apart. Exam table, because I don't know what I'm going to put in between them, if anything. Student, exam. Keep track of which students are entered for which exams. They get entered for exam. So a student will get entered for an exam. So that might be the connection there. Each exam takes place in one room and can involve any number of students. One room can be used for any number of exams. So I'm going to need a room as well. Okay? So my room tells me which exams students are doing. Now, I would probably go as far to say is I'd probably have an entry table that keeps track of entries for these students. And that might be quite hard for you to spot there, but I reckon that's a good move because which students are entered for which exams. Each exam takes place in one room and can involve any number of students. So each exam takes place in a room, one room. A room can a room have many exams? Yeah, any number of exams. So that means if a single room can be used for many exams. Okay, so I hope you can see that one there. One room can be used for any number of exams. Each student can be entered into any number of exams. So one student can be entered into any number of exams. which includes the room's capacity and whether or not it contains computers. So what about this exam stuff here? A college uses relational database to keep track. I have to read about 16 times. Which student are entered for which exams? Each exam takes place in one room and can involve any number of students. Okay, so think about this then. An exam. Do you have one entry for an exam? Yeah, so a student is entered for one exam only. Okay, right, that makes sense. A student's entered into one exam, one student in one exam. So it's like you doing your computer science. You're entered in for one computer science exam, even though there is two, but it's one subject. Then you've got an exam can have many entries. So that's just using my common sense. An exam can have many entries. So a college uses a relational database to keep track of which students are entered for which exams. Each exam takes place in one room. So an exam takes place in one room and can involve any number of students. One room can be used for any number of exams. Each student can be entered into any number of exams. Information is held. So this part here really is just the common sense part for me, making sure I'm working that out. And then the students' entries in the rooms, I'm happy with that. And I would get 3 marks for that in total. So we'll have a look at another one of those. Now these are all old specification questions here. So I'm looking at the comments again. I keep going quiet because I'm looking at the comments. Okay, so I hope some people are actually going to review this back, because clearly focused on the comments. I'll be streaming until 9 o'clock because I'll let you get on with your revision. You don't have to be concentrated on all of these different comments on the side like I am at the minute. It's interesting what people are putting. Okay. Any number of students can be entered into one room. That last comment, yeah, it's a good comment. However, the relationship does that through the entity itself. So a student can have many entries and then they get entered into an exam, and the exam's done in one room. But the room can have many exams in there, like computer science, maths and physics, for example. And the exam can have many entries. So obviously computer science will have 73 entries tomorrow. And that all works through that relationship there joined. So let's have a look at another question. I literally thought I turned it off then. It's a good question. Prioritizing for revision. If you've looked through the questions itself, okay, I'll quickly, just before I get stuck into something else, I'll quickly look there. If you just look through the 2016 paper, now it's hard to predict what's coming up because it's 3 years. Now I definitely know that you're going to get an algorithm of some sort of maybe a dry run or a question to pseudocode. That's a definite. You're definitely going to get data representation, so binary, and you're definitely going to get Boolean algebra. Now, in the 2016 paper, you had all the binary stuff. Then you had a CPU, so that was the first chapter. You've got solid state drives, so that's storage, handshaking, so that's networking. You've got all your data representation, beginning data representation stuff, and this is sort of memory requirements. So you've got ASCII there. Then you've got methods of investigation. So if you think about your methods of investigation in the software development lifecycle, you've got your observation, you've got your questionnaires, and things like that. It says 2 different methods of investigation there, so you could use any of the 4. You've got Computer Misuse Act, 1990. Now, legislation, that was the only question that's come up so far, I believe, about legislation. There's not an awful lot that they've asked on legislation so far, so that might be an area just to touch up on, especially on the bits about how you can get out of the legislation or exemptions from the legislation, should I say. So that covers your data representation. You've got this one here, a linear search pseudocode. Now, across the 2 AS and A2 papers, we've covered all of the searches and sorts. Remember, the only ones you need to know at AS are the linear and binary search, and then you've got the sorts, which is the bubble sort and the insertion sort. They're the only 4 that you need to know. You've got a bit of Boolean algebra going on. Open source software. Remember, you've got bespoke, open source. Okay, and your open source software is licensed, open to anybody. You've got your bespoke software, and you've got your off the shelf software. Off the shelf is things like Microsoft. Your open source software, like I said, is open to anyone. Like the Linux kernel, they built any operating system off that they wanted to, and that's open for people to use. And you've got bespoke, which is very, very expensive, but it's custom to what you want. Okay. Then you've got syntax analysis in the compilation process, which we've been through already. You have to dry run this algorithm, which is the sort. So they give you 2 in this paper, which is pretty harsh. And you had to dry run this one, and I get told why it would fail. Procedural programming paradigm and object-oriented approach. Then you've got modes of operation. Now, this question really stumped my first year group. What is a mode of operation? There's 3 types of modes of operation that you need to talk about. You've got real-time control, real-time transaction, and batch processing. Okay, so real-time control is controlling like the motors for your windows and your greenhouse. So it's a constant input of your temperature. You have real-time transaction, which is your cinema booking and stopping double booking. Then you've got your final one there, which is your batch processing. Okay, and batch processing is your master and transaction files, and it's no human interaction apart from pressing go. Running it, complex calculations, very repetitive, and if there's any errors, it doesn't stop, it puts it in an error file and continues onward. And that was the big 12 marker. You will get a large mark question at the end of your paper. In 2017, define the term internet. You could have said a network of networks. Then you've got which protocol. You've got the fetch, decode, execute cycle, which is the question I was talking about before for 4 marks. You've got explaining the term parallel processing. So remember, parallel processing is the breaking down of a problem into subproblems and putting them on their own threads in order for them to run. If you're running the program split down, then you can get concurrency problems and a new class of software bugs, basically. But it's much more efficient, it's faster, and that's the point of it. Converting numbers. So again, there's your binary, more binary. Advantage of representing numbers in integer form than floating point form. You've got state what is meant by the term algorithm and 2 methods of defining algorithms. So how do you write algorithms? You do pseudocode or structured English or even flowcharts. You've got write an algorithm, 7 marks to produce whether it's odd or even, okay? And that's going to use mod by 2, okay? Remember, mod gives you the remainder of a division. So whatever you mod, if you mod 2 with everything, it's going to return 0, then you know it's even. You've got your standard Boolean algebra. You've got another sort here. And then you want you to dry run the sort, tell you what the sort is. I think that was an insertion sort, that one. And you've got selection. So remember, selection's if statements in here. So you're looking for your if statements, which is there. You've got repetition. Repetitions you do, or your for. You could have had any. They're all loops. Features of markup language, program paradigm. So explaining the things I was talking about, chevrons, closing the chevrons with a forward slash, providing markup or meaning to plain text. Lossy compression techniques. So remember, lossy and lossless. Lossy compression, you're never going to get it back. You're hiding pixels or audio that's not visible or audible by the human eye or ear. And lossless compression is used on textual data because you can get it all back. Lossy is never used on text. Describe the terms file and record within the computer system. Well, a file is a collection of related records, and a record is a collection of related fields. Explain what is meant by fixed length and variable length. Go and watch the video if you've not seen it. Kevin is not live on this, by the way, or Phil. Oh, Kevin's watching. Okay. Hello. How do you know Kevin's watching? Okay, never mind. Anyway, so 11 was all about index sequential. Remember, there's 4 separate file handling methods: serial, sequential, index sequential, and direct or random access. So watch that video because that seems to be a popular question. The C there, draw a clearly labeled diagram, okay? It shows how a transaction and master file is used to produce a monthly bill. So if you don't know what that is, okay, Kevin probably shown you, and so did Phil. You've got a nice process in the middle, which is for your bills, so make sure you write the process in. You've got a couple of different strands in a transaction and master file. So this is for that question. Okay, this is for the clearly labeled diagram that shows how transaction and master files are used to produce monthly mobile phone bills for each customer. Okay, that's what this is for. Now, in this, you'll have, I call them snails, but they are your magnetic tapes. So they are storage devices, old school storage devices that the college used to use to store student records. But in this, they were used like hard drives were back in the day. So you've got your sorted transaction file. You've got your master file. Okay, the best example to use for this really is like a phone company. Think about the amount of calls that are made per day. If they stored all them in a file and you had to access them all, can you imagine how long it would take to find something like that? Billions and billions of calls a day. We store it in a smaller file called a transaction file, which might be your day-to-day or your week-to-week log, basically. And then every week or every day, we'll update the master file. And if this sorted transaction file is actually sorted when it comes in, then this means that when you do the process of updating and you produce your bills in the end, so this might be your bill, with my bad drawing, you'll get your updated master file. Okay, updated master file. And if your transaction file sorted, then that means your master file will always be sorted. And like I said, this is a batch process, so this is going to continue to run over and over again, because you're not going to sit there and produce millions of bills by hand, are you? No, you're not going to be that stupid. So here, if there's an error, you don't want to leave the office, and this process happens overnight, so you don't want to leave the office and then come back in the morning and realise that 3 had been done and you've got to do the rest of the other million, okay? So you'll have an error file, okay? Now, your error file will hold any errors that couldn't be processed and turn into bills, and this will be done manually by a human on the next day, okay? And that's that question for 4 marks. Then we looked at the role of the operating system in managing resources. So what does the operating system actually manage? Because this is a question that a lot of people don't actually get correct. So you've got to think about all the inputs and output devices that you've used. So the printers, the monitors, the keyboard and mouse. Think about spooling in your printer, that you can send something to a buffer and it will store it and print it out when you shut down your computer or whenever you like, and then it's stored locally on the printer. Your operating system sends that and manages it. Also manages it locally on the computer. It manages the backing store, so ensuring that data is stored and retrieved from disks, that's your secondary storage devices. Your operating system, it will maintain what they call your filing system. So if you use FAT or NTFS, so FAT is the file allocation table, or NTFS is your new technology file system. So I know Mac uses NTFS and Windows also uses NTFS and FAT. So that's just how you organise it. It's your address and your pointer to data, really, and that's what your operating system manages. What about your hierarchical data structure? Somebody was asking this question before. Let's have a look. Let's have a look at that. So back to the comments again. Yeah, a lot of people saying hello to Kevin. if he is there or not. It's the Phantom Kevin. So let's let me add a new layer. Let's get rid of that. So think about, what is a hierarchical data structure? Well, if I've got my computer science folder, I might have my computer science folder split down into AS Computer Science, and I might have it split into A2 Computer Science, okay? And then I might have AS Computer Science split into Component 1, and I might have AS Computer Science split into Component 2, and I might have A2 split into Component 1, I might have it split into Component 2, and they also do a coursework, so that'll be split into Component 3. Now, this is what we call a hierarchical file structure, and this is, believe it or not, this is the granddad file, or what you cool kids would call the OG, okay? This one here would be the father file, and this one would be the son, okay? And it keeps going. You know, you get the grandchild and all sorts of stuff. You just keep going and going and going. And this is what your operating system actually manages also. We've also got compression. So the operating system will compress and save disk space. The operating system manages memory or RAM. And it can even control virtual memory, if you know what that is. So if you've run out of RAM and you use your secondary storage device, a portion of it can be separated. Kept asking this, and this is simple. Oh my god, I feel. Don't worry about it. Don't worry about it. There's no such thing as a stupid question. But your operating system can manage your RAM. It can schedule things. It can schedule process states onto your processor. Virtual memory, so the section of RAM in your hard drive, it can control, but it's still really slow. Remember, if you're using virtual memory, it's still really, really slow because it's your secondary storage device, remember. And transfer rates don't increase. So, what about multitasking? So when using your computer, you might have several screens open, like I've got several hundred screens on now with my... please, book paper 2 is on Friday. What? Oh, okay. Someone's listening to this in the car. So whoever's just... I mean, if you've asked about requirements, you need to explain yourself a bit more. Requirements for the exam. I don't know what you mean. Okay. But that's 10 marks. So that was the 10 marker on that year. Then we got to the 2018 paper. So this is the AS students last year. Okay. And they had to talk about the importance of network standards in the first question. So what is the point in having a standard, a network standard, like a protocol, for example? You can't create networks without standards. And in order for us to speak the same language, we need to agree on this beforehand. Network standards are easier to develop when everyone's speaking the same language, and different companies can work together, international or local companies or whatever. They can all work together if we're all communicating using the same protocols, for example, and we're not forced. If we've got a standard we all agree to, we're not all forced to use one vendor over another one, and we don't have to pay more or get better rights to something else or whatever, and that leads to competitive pricing and things like that. You've got 1B, again, it was standard protocol stuff, and then describe how traffic is routed in a packet switch network. So think about packet switching. Packets are split up, okay? So one program will or one piece of data will get lots of different pieces of data, get split up into little packets. Each packet has a destination address, and packets are analysed by each node. All right, they sent down the most appropriate path to reach the destination, and that means that they've got good fault tolerance. Okay. Oh, John's back. You're a fraud, and so is Phil. Okay, someone's clearly bitter. Maybe John Barker's Kevin. I don't know. Who knows? Anyway, so packets are sent down the most appropriate path to reach its destination. Each node maintains its own routing table. So when you send things to your router has an address table that connects to other routers and other nodes and it could be servers in your network. And then it goes to that server, and that server has a table, and it goes to that node, the server switch, whatever, has a table, and it can keep going. So your packets could take different routes. The only problem is, think about the extra processing at the end. Combining all the packets together, that's going to take some time. Then you've got, compare the functional characteristics of a solid state drive and a Blu-ray optical drive. Okay? Now, this stumped a few people. Think about it. Solid state drives. No moving parts. I'll say that now. HDD, moving parts. These are really easy to compare. HDD works like this. It has platters. Each platter has iron oxide, which is a magnetic material, okay? And that gets polarized to a 0 or a 1. Your read-write head moves across the disk, and it will read what polarity has been set by a magnet, basically, all right? Now, the moving process, as you delete files, what you're going to do is you're going to create space on your disk. So everything on your disk starts to break up. And retrieval becomes longer over time. Okay? Now, SSD doesn't have that problem. It uses NAND flash memory, which is actually shock resistant. Whereas if you drop a hard drive, potentially, just having a drink because I'm dying. Potentially, if you drop your HDD, the platter, if that read-write head touches the disk, it's game over. It's going to scratch the disk and that's it. All right. So solid state, non-mechanical, NAND flash memory on circuit boards is very, very quick. So SSD has a faster data access than both the disk and the hard drive. So the files are stored on microchips. It is non-volatile. Okay, so if you think about volatile, if you turn off your power, like RAM is volatile, if you turn your power off, all the data is going to get lost. Whereas on your SSD, for example, and your HDD, it's non-volatile, so it's going to keep that information. Blu-ray, optical drives, the reason why Blu-ray is called Blu-ray is because of the wavelength that it uses, okay? And the wavelength gives a blue light off, that's why it's called Blu-ray. So it uses lasers to store data, and it burns microscopic indentations into the disk, okay? And these are called pits and lands, L-A-N-D-S, okay? This pattern of indentions is created in a spiral pattern, all right? It starts from the middle and it works its way out. And then the laser, the reader, will read what has actually happened to the disk, all right? So the laser's aimed at the disk and reflected back, and when it can cause interference with the original laser, which is a bit of an issue, but Blu-ray is stored on 2 layers. So Blu-ray data can be stored on both sides of the disk, which obviously increases the capacity. And 2 lasers of differing wavelength, which is why you get the Blu-ray, is used to read data from the 2 layers. And the reason why Blu-ray is better is because the laser can actually put the pits and lands closer together. And that means you've got more storage space again, so you've got double-sided and also the close together. And it's non-volatile. So typical storage for SSD is about 500 megabytes up to 4 terabytes, which can obviously get expensive. And then you've got your Blu-ray, which is 25 gigabytes to 128 gigabytes on average. So what is an SSD used for? Well, any programs, your operating system, server backup, phone images, whatever. Blu-ray, what comes on a Blu-ray disc? Usually your PlayStation, Xbox games, or a movie, a film, whatever. Okay? So, I'm not drinking Lucozade, Logan, no. I wouldn't do that to my body. So I'll finish off this paper, and then I'm happy to finish off any questions that people have got. I'll literally just go and answer questions in a minute. Can we get this till 9:30 or 10? No, this is overtime. No one's paying me for this, unless you start donating. I might put a donate button on. You can all start paying me. All right. Just looking at this question 3 here, truth table. You've got demonstrate a process that can be used to discover the state of the most significant bit. So obviously, that's masking. Demonstrate how this register can be cleared, or clearing. How do we clear a register? That's interesting. To clear a register, you take the original data and you AND it all with zeros. AND it with zeros. Okay? It's not Logan. I'm drinking water, by the way. Yeah, that's a good point. Patreon. Yeah, it's against my code of conduct to actually take money. Please, we need this. Well, people are obviously panicking. Right. So, describe the difference between fixed and variable length records. Okay? Fixed and variable length records. Now, fixed length records are obviously fixed in size. What's the benefit of that? Well, you've got the same number of bytes in each record, same number of fields, whereas variable length record has a different number of bytes in each record or different number of fields. Bear that in mind. Fixed length records are easier to program because it can be calculated how much space you're going to need and how much will be required. So variable length records make it difficult to calculate how much space will actually be required. So when you're searching for things, you might have to do it in a linear fashion to find it in a variable length record, whereas fixed, you can go directly to the start of the record and then do your linear search, which obviously speeds up searching. Okay? Fixed length records, the problem is you've got to pad out to the required length. So if you're using a data type like a Boolean that takes 1 bit and you've got like a 10 bits reserved for it, you've got to pad it out to 9 more bits, which is a bit of a faff. And that's obviously going to waste space. So variable length records, they don't have that problem. They can save storage space because there's no blank space needed. Okay? Add a super chat. Turn on donations. It's like you want to give me money. Anis, no, Raid. Raid is additional. That's one of them. Raid is one of those sort of accepted but not expected. Donate to buy John a face cam. Okay, no. So think about that. So fixed length records, they can truncate long fields, but variable length records avoid the truncation because each field can extend to accommodate the number of characters needed. So that's a bonus, I suppose. Looking at this one, question 5, that is a disk platter. All right. So the following 2 files are stored on an external hard drive, file A and file B. Compare the difference in disk access speeds when loading file A and file B into main memory. So just look at it. Okay, file A is all on the same track. We call this a track going all the way around. So if you see that file A pattern, that goes around in a circular motion. The read-write head just has to sit on that track and read all the information from it, which is fine. Dead simple. And because we sit on that track, the read-write head doesn't have to move, which doesn't waste time. Whereas file B, it has to access across the tracks, across the sectors, and across the clusters. Okay, so 2 of these together is called a cluster, and a sector or a segment is like what you get in a Terry's chocolate orange, for example. So think of it like that. All right, and that's 6 marks. That's a lot of marks just for one question. So just by saying B will take longer to find than file A, I'll get you 1 mark. File A is stored on a single track, which is quicker for the HDD to read, the read-write head to read. Sorry. So the read head reading A does not have to physically move, and B is fragmented. B has been split up and physically stored on different parts of the disk. Fragmentation can be used to overcome this problem. So how do you solve it? That's a good point to make. Tyler, I'm not going to whisper into the mic. That is just strange. God, what is wrong with you people? We do, John. Why don't we? Yeah. Wow. Okay. My students are obviously going to do well. Look at these comments. Yep. So let's have a quick look through this. Converting again. Binary again. Same questions. Same layout again. Give 2 advantages of representing numbers in integer form and 2 advantages of representing number form. So what is the benefit of integers? Well, numbers are stored accurately because you don't need any floating point business. They're less complex to process, and there is an exact representation of 0. If you think about it, sign and magnitude in floating point form, whatever. The bit can be 1 or 0, Okay, so you change the 1 bit to 1 and they're all zeros. You've got a negative 0 and a positive 0. Just think about that. So less storage space is needed in the end. But floating point form, it's got a couple of advantages. So very large or small numbers can be stored. Larger range of numbers can be represented, and fractions can also be shown. Whereas in an integer form, it can't be. It's whole numbers only, unfortunately. What else have we got? Yep, that's that question I was talking about before. So the minimum storage requirements. That's not too bad, really, because a Boolean is 1 bit. Remember, ASCII can be 8 bits, or 7 or 8 bits, depending on what you want to use. A string is 7 or 8 per character, and a short integer is 16 bits. You can work that out by the range it's given to you. How many bits would you need to store? Negative 32,768 and positive 32,768. Okay? Michael, no amount of flattery is going to save you in this exam. Let's just be honest. What? Logan, stop it. So, we've got an algorithm, Betty's Bakery. We've done that in class. We have main features of batch processing. One thing I'll just explain actually about Betty's Bakery and these algorithm questions. How are you going to get the marks? Remember, initialize declare variables. If it needs a procedure, then write the procedure and end the procedure. That's important. A loop, maybe. You can have a loop or some kind of selection will get you some marks. An import of some sort is going to get you some marks. Validation, if it asks for it, is going to get you some marks. Having the correct mathematical conversions is going to get you a mark. Mod or div. Remember, div is just the straightforward division. It's the integer. So when you divide something, you just take the whole number. And mod will take the remainder of the division in there. Okay? And then obviously, make sure you end all your loops and stuff like that. Okay, nice, right, well. Interesting. Yeah, still going on those comments. I've never seen you lot write so much. Okay. 9. Describe the main features of batch processing. Well, we've been through that. Yeah. That would be suitable for this mode of operation. Batch processing. No human interaction. Click go, get it done. When does it happen? Off-peak time. What's the point in doing that? No load on the system. It's faster. If there's any errors, error file. Come back in the morning, sort it all out. Boolean algebra, standard Boolean algebra question for 8 marks. Insertion sort algorithm, but contains an error. Well, you have to find the error. Okay, so you're going to have to run it and look at it. Describe the term sequence in algorithms. Okay, remember sequence, selection, iteration. So sequence is the specific order in which the instructions are performed within an algorithm. Okay, instructions are carried out one after another. So, for example, I is integer is going to happen, then j is integer is going to happen, and then n is integer is going to happen. There's no jumping around the code. Okay, insertion sort algorithm operates, sorts as it goes. You take the first term, compare it to the second one. If it needs to swap, then swap. Keep going, just like a bubble sort, until you get to like the third term. You compare that one against the one you're at, and then you would compare it all the way down the list behind you, and you get a sorted list as you go. Okay? So fix the algorithm, that sort of stuff. Name and describe a different sort algorithm. Well, there's only one left. There's only one other one. Bubble sort. Name and describe different file attributes. Oh my goodness. Right. Let me just fix this one. This is important, this one. The whole country really did garbage at this. Looking over again at these comments. Yeah, I'll see some of you next year if you make it. If you make it. Okay, first 2 questions we did on Friday. Will I give them such little marks? Those questions will be. It'll be more marks, Logan. Don't you worry, I hope. Will you do programming live stream for this 2 job? Programming live stream? This is hard enough, doing this stuff. It depends. It depends how many people like and subscribe. So, there we are. Yeah, looking. Fine, so leave it. Yeah. Yes, Logan, I said that right. So let's have a look at file attributes. Oh, look at this. 11 minutes past 9. What are you people doing to me? Right, file attributes. This is really a GCSE thing, but file attributes. So, different file attributes we've got. Let's start that again. Read. You've heard of these. As soon as I say this, you'll know them. Read only. Okay? This is obvious what it does. Read only. So when the user is unable to alter the file. Yeah? Read only. Simple. There's another one called archive. Okay? Archive. So this is when the file no longer in regular use but may be required sometime in the future. We archive the file. Okay? And we don't copy it, we don't delete it, we move it to a new area. Okay? I remember telling my students about archiving and backups. System. Okay? Weird one. System. This is when the file is only used by the operating system. So this, an example of this, right, a good example of it, is something called a device driver. You know what a device driver is? Plug and play stuff. Then you've got the last one, hidden. Something called hidden. So this is when the user is unable to see the file. So for example, many files are hidden in Windows because the user can't view them, they can't amend them, and this might be important for security or something like that, or you might just not want them to mess with the system information. Okay, so it's like what we do in college. We hide the system32 file, so you can't find it. If you know where you're looking, you can, but you can't find it. That's the point. Yeah, it's hidden from you because you're all dangerous. Okay, so 4 different things. Read only. Oh, I messed it up. Read only, archive, system. So remember, system is when the file is only used by the operating system because that's when you don't hear very often. And you got hidden, so this is when we hide things from you for security or protection or whatever. Okay. I'm not planning to stop T-Series, whoever that is in the comments, right? I'm going for PewDiePie first, and then I'll take T-Series down after, all right? I don't know who half these people are. Bet they don't even do computer science. So, looking at the 2018 paper, third one, so different file attributes, and then we had the 10 marker. A systems analyst has been commissioned to produce a new computer-based system. Remember, now, as soon as I read analyst, I'm thinking software development lifecycle. Discuss the ways in which a systems analyst could carry out an investigation and analysis, so think about investigation and analysis to ascertain the needs of the client and describe the possible effects of increasing the use of computers in the workplace in terms of nature of employment and wider society. Well, they have opened a can of worms there to all sorts of stuff. All right? So what they were looking for is the investigation and the analysis part of the software development lifecycle. So the study, you can study the existing system documentation, explain the benefits of that. Okay? So the analyst can see how the current system should be operating. It's an inexpensive method of gathering lots of information fairly quickly, and they can identify the storage requirements needed because look at the question, okay? Discuss the ways in which the systems analyst could carry out an investigation and analysis to ascertain the needs of the client and describe the possible effects of increasing the use of computers in the workplace in terms of the nature of employment and the wider society, okay? Then, you have to talk about the drawbacks. This is a big 10 marker. So staff may not be following procedures, so you might be looking at incorrect procedure management. And then in the documentation, that's going to have a knock-on effect, isn't it? So documentation may be out of date also. So if you're looking at system documentation, it may be out of date and not updated to reflect the system changes. You can carry out a questionnaire of the staff, which is a relatively cheap method to produce a large input or data set. It can be distributed also worldwide. So if it's an international company, you can send it all over the place, and it could be completed online, so results can be available fairly quickly, but you might not get them all back. That is a problem with questionnaires. So they have to be designed by experts first, because apparently they're really hard to create for some reason, and people are often too busy and may not complete them, and they don't give the correct answers because the people are just, well, humans are humans, and they always lie. Okay, so that's a summary of the 3 papers in total. Yeah, so I'm hoping tomorrow's paper will be fairly straightforward, but you never know with this exam board. What I'll do is I'll look at the questions that people send in. If there's anything specific that people want me to go through or look at or even answer questions on, then I'll do that. But I'm not hanging around forever. So what have we got? Let's have a look. Michael, if you don't know when the exam is, that is worrying. Okay. Well, at least one person found it helpful. Oh, thank you very much, Kevin. Right, so for that person, just quickly, that person that mentioned parameters, okay, parameters. You've got value and reference parameters, okay? So the value and reference, remember, value is a copy and reference, oh, correction. No problem, thank you. So, I'm just checking those questions. Does anything else people want before you leave? If anything else wants me to go through anything, just let me know. But I'm almost ready to go. Two's complement and binary addition. Yeah, I can do that for you just a sec. Okay, yeah. Do that. So, best way to think about this is this is the original location. Okay, so how do you spot if I've got a calculate function or procedure? Parameters come inside parentheses. Okay, so this will be a parameter. So it's what you pass in. Now, if the calculate procedure is going to use the value, this is going to use a copy of it. So this is when I don't change the value of the parameter itself. Okay, I'm only using the value of it, which is a copy. If I try to send it back, it won't change the variable in its original location. The reference parameter, however, if I send in by ref, you might see this in VB, by ref, okay, that passes the original memory location in. So that passes the memory location in, and that means that when I return the value, it's going to go back to the memory location and alter the original value, okay, of the reference parameter. Okay, so for that's that one. Yeah, I will put, yeah, donations, yeah, no problem. Do it, yeah, okay, yeah, okay. No ASMR. No, sorry, Tyler. Sorry to disappoint. It didn't cure world hunger either. I'm still not people's dad. I don't know what that's all about. Make a TikTok. No, thanks. So quickly, just for Ethan. 2's complement. Right, let me just quickly recap 2's comp for you. Let's do something really, really simple. So, oh my goodness. I pressed the pencil. Right. 0, 1, 0, 1, 0. Okay. So 1, 2, 4, and 8. So this is 5 bits, and that represents the value of 10. Okay. I want the value -10. So this is the 2's complement method. Okay. Now, all you need to do is you go up to and including the first one, and then you invert the rest of the bits. 1, 0, 1. Now, what does this actually do to produce -10? Well, it takes the 16 bit that was there. This now says 1, 2, 4, 8, and then -16. That's 2's complement, okay? 2's complement, the most significant bit becomes a negative bit. So you've got -16 plus a 4 plus a 2, okay? So if you think about that, -16 plus a 4, -12, plus a 2, -10. And that's how 2's complement works, okay? So up to and including the first bit, invert the rest. All right? That's that. Yep, Kevin's right. You can check out my other videos if it's helpful. Thanks, Kevin. Yeah, he's going to watch them all. Yeah. And just remember the rules for binary addition. 0, 1, 0, 1, 0. And 0, 1, 0, 0, 0. Binary addition, 2 zeros is going to give you 0. A 1 and a 0 is going to give you a 1. 0 and a 0 is going to give you 0. 1 and 1 is 0. Carry the 1. 0 and 0 is 1. Remember, if you get a 1 and a 1 here, let's say I had 1 and 1 here, and I had a carry 1, it would be 1, 1 and 1 is 1, carry the 1. And this is an overflow bit. You disregard it. It doesn't count towards the value. Okay. Yep. Like and subscribe, people. Okay. Yeah. Mm-hmm. Thanks, Jordan. Yeah, you can invert them all and add 1. Yeah, I do need a pay rise. Yeah, and I am a legend. Yeah, you're all very correct. Yeah, thank you. All right. So, Michael, it's not 10. Good luck in your exam, people. I'll see you tomorrow bright and early. Set your alarms. Have a good breakfast. And let's smash it. See you later.